13, 14, and 15. I'm probably going to say this wrong, but you're using de Moivre's theorem. I'm sure that's got to be a French guy, so if I spoke French, I'd know how to pronounce that. To find something to an exponent. I probably don't want to have to take 2 plus 2 square root of 3i times itself 6 times. That would not be very much fun. So this guy came up with this formula. I'm going to grab my paper here so I get it written down correctly. It says that if I have something to the nth power, what I'm going to do is take r to the n times the cosine of n times theta plus I times the sine of n times theta. Excuse me. The r again is your radius. So again, we're thinking about having our right angle. And if I was at 2 and 2 square root of 3, ignoring the I, I'm finding this value here by using that formula we use for magnitude, or just finding the radius using our Pythagorean theorem. So r is going to be the square root of a squared plus b squared, just like we've done a million times up to this point. Or at least it seems like that. So r is going to be the square root of 2 squared plus 2 square root of 3 squared. So 2 squared is 4, 2 square root of 3. If I'm squaring that, I'm taking 2 square root of 3 times 2 square root of 3, which is 4 square root of 9. That would make that 4 times 3, so that would give me 12. I end up with the square root of 16, which is 4. So I'm going to have a 4 to the 6th power, because this was to the 6th power. So I'm going to have 4 to the 6th. Now again, I have to find my angle. And just like before when I found my angle, I am going to use the tangent is opposite over adjacent. So I'm going to use the inverse tangent of 2 square root of 3 over 2. So that would mean I have the inverse tangent of square root of 3. Now, this is going to be in degree mode, so really if you wanted to use, or no, it's actually in radians they're going to use it. We are going to just use that table that we had before. I'm not going to flip over to the table right away because then erase my whole board. But this table here that we had, all of our angles between 0 and 2 pi, or with our sine, cosine, tangent, and all of those things. We're just going to use the tangent column in this case. But I'm going to look for, we are in quadrant 1, and I want to find the inverse tangent of square root of 3 and what angle that is. So in quadrant 1, if I look under my tangent column for square root of 3, I see that it's equal to pi over 3. Suppose I could have used the degrees also. 60 degrees wouldn't make any difference which one you use. So I am going to have the cosine of 6 times pi over 3 plus I sine of 6 times pi over 3. Coming down here, I got to do some calculating. So 4 to the 6th power, 4 caret 6 is 4,096. Cosine of, here if I simplify, 3 goes into 6 2 times, so 2 pi, plus I sine. Same thing, 3 goes into 6 2 times, 2 pi. So again, I'm going to use this table, and I'm going to look up the cosine of 2 pi and the sine of 2 pi. So I'm going to have 4,096, the cosine of 2 pi. 2 pi, looking under the cosine, is 1, plus I times the sine of 2 pi. the sine of 2 pi is 0. Well, this is going to make this 0. So I'm going to have 1 times 4,096. So my answer is just 4,096. So if I took 2 plus 2 squared to 3i times itself 6 times, I would end up with 4,096. So again, just to make sure you knew what table I was using now that I can clear my writing, I'm using this one here where we looked up the tangent of square root of 3, gave us pi over 3. You could have used the 60 degrees also, but so I could convert it. Then I went down to the 2 pi, which is, I'd have to scroll down to get to, which I could do. 2 pi, and I looked up the cosine of 2 pi, which was 1, and the cosine, or the sine of 2 pi, which was 0. And so I used my table a couple different times in order to solve my problem. So make sure you have that table handy. We've used it a lot. You should have it somewhere. If I go back to number 14 then. So number 14, we're using that theorem to find -1 plus I to the 5th power. So I'm thinking about having -1 and then a +1 because that would be a 1i, right? This would be -1 plus 1i to the 5th power. So I'm over here in quadrant 2. First of all, I'm going to calculate r. So I am going to do a squared plus b squared. So -1 squared plus a +1 squared would be 1 plus 1, square root of 2. So r is square root of 2. I'm going to have the square root of 2. I'm going to raise that to the 5th power. I'll get on with the rest of it here in a minute. So then I am going to figure out my angle. My inverse tangent is going to be the opposite over the adjacent, so 1 over -1. So I'm doing the inverse tangent of -1. And again, I'm just going to look this up on my chart here. I'm looking for in quadrant 2. So for quadrant 2, you'd be between the 120 and the 180. You're looking for the inverse tangent that's equal to -1. So looking there, I have 3 pi over 4. So I'm going to have cosine of 5 times 3 pi over 4 plus I sine of 5 times 3 pi over 4. So first of all, if I do the square root of 2 to the 5th power, 2 to the 5th power is 32. So I'm going to have square root of 32. I could simplify that, but I'm going to wait till later to see if I need to, depending on what my multiplying is. So over here, I'm going to have cosine of, that doesn't cancel, so I'm going to get 15 pi over 4 plus I sine of 15 pi over 4. Now 15 pi over 4 is more than 2 pi, so I want to think about when I have my thing that I'm going around, and how much farther do I have to go around? So I'm going to take my 15 pi over 4 and subtract 2 pi from it, because I'm trying to find the equivalent angle that's between 0 and 2 pi. So this would be 8 pi over 4. 15 pi over 4 minus 8 pi over 4 would be 7 pi over 4. So I'd be way around here at 7 pi over 4. So I'm going to do the square root of 32 times the cosine of 7 pi over 4 plus I sine of 7 pi over 4, using my equivalent angle that 15 pi over 4 is the same angle as 7 pi over 4. Then I'm going to look up in my table. So 7 pi over 4. The cosine is square root of 2 over 2. So I'm going to have the square root of 32 times positive square root of 2 over 2 plus I times negative square root of 2 over 2, which is the sine of my 7 pi over 4. So when I multiply this out, I'm running into the next problem, but that's okay. The square root of 32 times the square root of 2 would give me square root of 64 over 2. The square root of 64 would be 8 over 2. 8 over 2 is 4. Same thing here. I'm going to have I, and then I'm going to have negative square root of 64 over 2, which would be negative 8 over 2, which would be negative 4. So I'm going to have 4. Negative 4 times I would be minus 4I, and that's as far as I can simplify that. So if I would take negative 1 plus I times itself 5 times, I would end up with 4 minus 4I. If I hadn't taken so much space up here, I probably would have fit that all in that section. So hopefully you wrote a little better than I did instead of scribbling everywhere so you could get it all to fit. Last one here. I'm going to clear the board so I've got a little more room, but it won't let me go up any higher. So I'm going to do 5 minus 5i to the third power. I could take 5 minus 5i times 5 minus 5i times 5 minus 5i, but I can use my theorem here and hopefully make it a little simpler. So again, 5 would be here, minus 5 would be down there. I'm going to be in quadrant 4. So my radius is going to be 5 squared plus negative 5 squared. 25 plus 25 gives me the square root of 50. And again, I would simplify that, but I think I'm just going to wait and simplify it later. I'm going to have the square root of 50 raised to the third power. Then I'm going to have the cosine of figuring out my angle. Inverse tangent, opposite over adjacent, so negative 5 over 5 would be the inverse tangent of negative 1. I want to be in quadrant 4. So I'm going to look on my table, down in quadrant 4, between the 300 and the 360, inverse tangent equaling negative 1 would be 7 pi over 4. So I'm going to have 3 times 7 pi over 4 plus I sine of 3 times 7 pi over 4. So, if I take 50 to the third power, 50 to the third power, I'm going to have the square root of 125,000. Maybe I should simplify that, but I'll wait and see if I need to. Here, I'm going to do my cosine. Again, I can't cancel, so I'm going to get 21 pi over 4 plus I sine of 21 pi over 4. Again, that's bigger than 2 pi, so I'm going to figure out what my equivalent angle is. So if I went around once, I'd take off 2 pi. 21 pi over 4 minus 8 pi over 4, which is the same thing as 2 pi. 21 minus 8 gives me 13 pi over 4. Again, that's bigger than 2 pi because it's more than 8. So I went around once, I'm going to go around again. So I'm going to take off another 8 pi over 4, which is the same thing as 2 pi. 13 minus 8 gives me 5. 5 pi over 4 is where I'm going to be at. So 1 pi over 4, 2, 3, 4, 5. I'm going to be down here. Not that that matters. So, just because I have room to scribble up here, I'm going to rewrite this. I'm going to have the square root of 125,000 cosine, and we change this. That is equivalent to 5 pi over 4. So 5 pi over 4 plus I sine of 5 pi over 4. So square root of 125,000 cosine. Whoops, I don't even going to write cosine. I got to figure out what my cosine of 5 pi over 4 is. So I'm going to look it up in my table. 5 pi over 4. The cosine is negative square root of 2 over 2. Plus I times the sine, which happens to be the same thing. Negative square root of 2 over 2. So checking this out, I am going to multiply. So I'm going to have negative the square root of 125,000 times 2, which is 250,000 over 2. Let's see if that happens to come out nice. So the square root of 250,000, 1, 2, 3. Ha, it does. It comes out to 500. So I am going to have negative 500 over 2, which is negative 250. Because this was the same thing, I'm going to get the same thing over there. So I'm going to get negative 250 for my first term, plus I times negative 250. So I'm going to have minus 250i. And so I get negative 250 minus 250i if I would take 5 minus 5i times 5 minus 5i times 5 minus 5i. So again, I scribbled everywhere, all over the place. Hopefully you have some room down on the bottom of your page to write. But that's what I'm going to end up there with my answer. I could have probably started out this and simplified this. This was 25 times 2, and I would have had 5 squared of 2 and worked it like that. But since I'm using my calculator, I just left it alone. And I was lucky that came out to be a number that was a perfect square so that I could simplify it. But if you need to, or if it's not working out okay, you might try simplifying that before you cube it or do whatever you're going to do to it. Otherwise, at the end, you're probably going to have to simplify it, and it might not come out as nice as it did on this one, where it was a perfect square. So, negative 250 minus 250i is what we ended up with. So again, our theorem said that if we have r to the nth, or our z to the nth power, we are going to take r to the nth power times the cosine of n times our angle plus I times sine of n times our angle. And again, it's probably just as easy to use your sheet with your table of values in order to figure those things out.